Hi everyone. So today we're going to solve Leetcode daily challenge, problem number 909, snakes and ladders. So it's a really long problem statement to read, but essentially it's exactly like the board game we are familiar to play, in which you will have to start from the first block, which will be basically 0 0 of your of your indexing, if you say, and the pattern like the numberings are in Boustrophedon style. So it basically like I went through the Wikipedia article and it exactly means how these numbers are arranged. For example, 1, 2, 3, 4, 5, 6 is from left to right. Then in the next row, the order will be reversed. So that is exactly what it means. And if there is a ladder, you'll have to, follow that ladder to its top. And if there is a snake, you'll have to go to the tail of it. And all this information is beautifully, clubbed into the array which they have given, which basically represents, for example, the last array in the board represents the last array, actually last array. Okay. And -1 represents there is nothing like there is no ladder nor snake on that position. And if it's not equals to -1, then you'll have to basically jump to the square, which the number represents over here. For example, in the diagram, we have -1 over here. So there was nothing at the first block. Then there was 15. So basically, that there will be a ladder or something. Let's just don't assume we have a snake or ladder, but there is something which is indicating you to move towards this particular block. So you will jump to the block with the label 15. Then all other values are negative, negative, negative. So it's a single step if you want to understand that way. And we have to essentially find out the minimum number of steps which will take to reach the final block. Okay, so this is the scenario. And the first thing, like the first intuition after reading this problem was, can we use a Dijkstra algorithm or any minimum or smallest path algorithm? And the answer was yes, like we can definitely use the Dijkstra's algorithm or any other algorithm which you want to use with considering each path with a weight of 1. Okay. And what the path's going to look like, for example, from 1, you can go to, like they have given this formula over here. You can go anywhere between current plus 1, which will be 2, and minimum of current plus 6 and n square. So let's say n was 6, so 36 will be this, and current plus 6 will be 7. So all these numbers basically represents an edge between the nodes or between the blocks. But I thought like it's going to be a little complicated to implement that part in this kind of a setup. So I will try the solution with the BFS approach today. So let's move towards the solution, and I'll explain what exactly we are going to do over here. Okay. So my first aim would be to somehow align the given board setup with the indexing which we are familiar with. For example, if you go over here, this is basically 5 0 5 1. Like if you talk about the coordinates of it, right? Because 0 1 2 3 4 5, right? And it's a zeroth column. So 5 0 5 1 5 2 5 3 5 4. So I want the coordinates to represent these blocks, which will make my task easier for me. Okay. So let's prepare that first. To do that, what I'm going to do, I don't want to use the length function again and again. So let's initialize that in a variable n, and my cells will represent the board setup basically. I want to initialize that with none, and I want it to be n square times n into n and plus 1. So yeah, we will now get the cells. Next thing is a label, which I'll be using to represent the current block I'm in. For example, one will have 50, two will have 51, and so on. So this is it. And number of columns, of course, like will be the number of elements in at any array in the board array. Okay, so basically the length of this list. Okay, so columns is list of range from 0 to n. Okay. Next, we'll have to simply run a loop, and I'm gonna do that the negative, like the negative way. For example, I'll start with the with the fifth row, okay, and we'll move towards the up. So for row n range in -1, because we have zero indexing in Python, we'll go till the zeroth row, and I want to take -1 as my step. Next is I want to prepare my column data as well. So for column in columns, there is a typo over here. Sorry. Okay. Now I want to store data in the cells. So to do that, basically, first one is row comma column. Okay, and I'll increment my label by 1. So basically, at first index, like the first element is getting represented by 5 comma 0 in the example which we just saw. Okay, that's done. Next is, as we know, we are gonna get the data in what was that? Boustrophedon style. So I would like to reverse my array, like whatever we have in the columns right now. So we are good. Okay, so it should be COL. Yeah. Next thing is I want to calculate the distance to get to any particular tile or any particular block. Okay, and to store that information, I am initializing an array. Let's take -1 because there could be a possibility of having one as the value, and I'm not very sure if we can take float infinity as our value or not. And that should not be the case, but let's be on the safer side and have -1 as the distance because it is not possible, right? Uh, there is nothing called negative distance, so that's fine. Similar to this, I want to repeat the same thing in square number of times. We are good over here. Now I will be using a queue for this. So basically, we are using BFS approach. Sorry, a BFS approach to solve this problem, and it is given in the problem that it will always start with the first block. So to represent that, I have created a queue over here with one in it. Okay. Next is, of course, if the initial point is one, distance of one will be 0. So we are good till this point. Okay. Next is I want to run a loop till we have any value in our queue. So while queue, I want to run this loop. And what I want to do is I want each time, like when I run this loop, I want to take the first element from this queue. So current is queue dot pop from 0, from left basically. And now we had that formula, right? Like we had this formula with us, which mentioned in the question, where these all are the possibilities to move from a particular block on the board. Okay. So I'm gonna use the same formula to run a loop to check what can be my next position. Let's say next position in range current plus 1 and minimum of current into n square, right? N square is this, and of course, like we'll have to add plus 1 because the last element is not inclusive in the range function. Okay, so we are good till this point. Now we know what could be the next position starting with this particular block. Okay, I want to separate out my row and column values from the next position basically. So we were storing that in cells, and the next is next position. So basically, I'll get the coordinate of my um, next block. Okay, so we got this. Now the next part is getting to or to know the destination block which we will be at. So destination will be can we write it in a single? Yeah, I can. Code of row, comma, column. If so, basically, if there is any ladder or snake, I want to go to that. Else, it will be simply the next position. Yeah, done. Okay. For example, in the question we had a ladder on second block, which led us to 15, right? So with this logic, if there will be any ladder or any snake, we will move to the block which that snake or ladder is getting us to. So this part is done. Otherwise, like we'll simply take a single step and we'll move ahead. Okay. Now this is done. My next aim is to update the distance of this particular destination. Okay. So if I want to use the index of the destination if distance like if we haven't seen it like as of now, then it should be -1, right? Then what I want to do is I want to initialize the value with it will be distance of destination will be basically I'll see how many steps it was required to reach the current position. So list of current, and I will be implementing one in it. Okay, and the next step will be appending the destination in my queue. Okay, so queue dot append the destination. This is it. So now we have calculated all the destination and sorry all the distance between the points or the minimal distance between the points. Next thing which we have to do is just simply return the distance at n squared position. Okay, so n into n position. This is it. Let's submit the solution for the test cases. Okay, there is an issue. That's fine. The output is -1. It should have been 4. Let's see. Let's see. Um, so basically, it's a issue with the distance. So, okay, my bad. We need to check if it has not been updated yet. So it should be equal to -1. List index out of range. Okay, we are having this into. Okay, makes sense. Even minimum. Okay, seems logical now. Mm, okay, so it's still getting a negative result. Okay, let me check this out once. This is the offer value. Wait a minute. Q.pop and in next position. I'm traversing in current this. Minimum of this row column. Cell is next of position. Then distance. I am using if basically if there is any leader or snake, I want to go to that part itself. Looks fine to me. Else, next of position, that's fine. Test of distance is -1, distance is equals to distance going +1. This part looks good. Let's see if we have messed up something over here. Column, fine. Okay, give me the reason. Six and my bad, my bad, my bad. Okay, so the issue was with the loop. Basically, I just multiplied 2 into n instead of taking a square of that. So that was the issue. Let's submit for further evaluation now. Okay, so the solution got accepted and we performed decent, like we outperformed 58.6% of the submitted solutions. So yeah, thanks, guys, for watching out the video and stay tuned for the upcoming ones. Thank you.